Hey guys, what's up? Quick update. So, I was telling you guys I had the camshaft profile issues where I was basically having piston to valve clearance, zero almost. So, my first thought was okay, I can just send back the cam. We could take a couple degrees of intake center line advanced out, so that's basically retarding the lobe. They regrind the profile so it retards the lobe, and the valve doesn't open until this is basically going back down. The piston's going back down, and then the valve finally opens. So I was talking to the cam spec guy, and he originally thought that was a good idea, and then we started thinking together, and I'm like, okay, I'm going to lose a ton of power if I do this, because the more advanced you are in the intake, obviously there's a threshold there, but for a turbo motor of this size, you really want to be as more advanced as you possibly can without running into piston valve clearance. So my solution was to, I said, okay, well, I'll just notch the piston. So this is pretty much the final product is from what I came up with. Here's a standard one where it's, I can show you, yeah, okay, so here's a standard one where it kind of lifts, you know, the big hump like that, and it was hitting in this area. So that was my solution. Here's one of the first trial runs I used. You can see that's a little more proud, and then I kind of got further along, and I rechecked this cylinder, and so I had about 30 thousandths clearance. I said, okay, I need to go deeper on the next one, so I continuously got my method down where basically each one of these are 10 thou apart. I can go back and finish those up, but I want to get a method down and finish all the banks at once, basically. So from this cylinder I have about 53. This one I believe I have 65, and then I think I have 65 for the rest of them. Again, that is with the cam VVT fully advanced, so that's worst case scenario. Right now, instead of the spring, because I took all that off, I went in here and I actually, for the vanes, I locked it in one position, which is fully advanced. So that's worst case scenario. Now my tool, you might ask, okay, well, how do I really notch this? Because people take them out and they put them on the Bridgeport, and then you got to find a certain angle. And the issue with that is that these cylinder heads are actually on a compound angle, so the valves are not straight up and down, they're relieved back, and they're relieved either left or right, kind of like a Hemi. So that's why they call that a compound angle, right? So I didn't want to find that compound angle on the Bridgeport, have to set it up, you know, go through the whole thing. I was thinking about throwing it on the CMM, basically beeping around the guide boss and finding that angle, which would still be nice to do if someone else, you know, wanted to follow along with me, basically. So what I came up with, and I've seen it online done before, I did this on the lathe. So I found a reamer that actually fit the guides. I cut it to size because it was a little too long. I didn't want hit this the cutting point of the reamer actually hitting the backside of the guide, messing up my guide. So I cut it so it wouldn't do that. And then I welded on with stainless rod, because this is a high-speed steel tool bit. So I just pretty much tacked on a piece of 4130, 4140. It's like a preheat treat, pretty mild stuff. High carbon content, so I could harden it a little bit. And then I glued a sanding disc on. So this is like a wear. You know, I already finished one cylinder. And I stick a new sanding disc every time, so I kind of have repeatable results. So this goes in the cylinder head, goes in the intake side. Goes in the intake side. Let me spin this around so you get a little light. Goes in the intake side, and then I have this stop I also made on the lathe. And it pretty much just locates, see if I can get a shot, probably not in the best position to do this. It pretty much locates on, well, you can't really see it, but it locates on the spring boss. So it's pretty much a hard stop on the spring boss, so it can't go any further. So what I've been doing, I've been using a fresh disc every time, and then measuring from the tip of this tool, which is ground, to basically the top of this with a dial indicator or a set of calipers, basically that depth. And I'm controlling that depth. That way I can control how far I cut into the piston. So I don't want to go too deep, and I can't be too proud. So that's pretty much the solution I came up with. And then, so to actuate it, all I do is take my drill motor, attach on the cylinder is fully taped up, tape it in duct tape, take my drill motor, put on the head gasket, then the cylinder head, then torque it down, set my stop so the head's on, and then basically take the drill motor and then just go in real easy, real slow. It takes about 30 seconds per cylinder to notch that out. And while I'm doing that, I have the exhaust valve out of the cylinder head. So I take the vacuum cleaner and go on the exhaust port, and it's basically just sucking all the stuff up that I'm cleaning up, right? So nothing gets in the rings, or everything's taped up, so it's taped with duct tape. So it pretty much just goes right out the exhaust valve. I don't have any cleanup after it's done. It's nice. Anyways, that's where I am. I got pretty much this one to do. This is a virgin piston. I got to redo that, so I got to do this one, and then I have to redo, what is this, 1, 3, and 5. Basically, because those were my trials, and I was getting better and better, and then this one I finally hit my mark, and then hit my mark on this one, and this one. I'm about to do that one and then go back. Pretty nice, not too bad. Yeah. So I'll post pretty much an update when I'm throwing this thing back together. Okay, thanks.